Okay, so this is TDR311. My name is Himanshu Verma. I lead the team of our worldwide security specialists. Our team helps customers orchestrate and implement and adopt AWS native security services, and also help customers with their security journey wherever they are, either using native security services and/or partner tools. I'm joined today with two other speakers, Scott Ward, who's our principal solution architect, as well as a customer who's joining us to talk about this topic. So the topic that we're talking about today is securing data and democratizing the alert landscape. This is actually a very relevant topic when we talk to customers most of the time, especially teams who are working on either incident response and/or working on helping other businesses within their organization. And that's where Matt Derensky, who's the Director of Cloud Security from Comcast, will be actually providing some use cases and as well as examples on how their organization has leveraged some of these, and put these into practice with regards to use cases. So highlighting incident response and why this topic is relevant is because of some of the key challenges that we continuously hear from customers. And some of these might resonate with you as well. First and foremost, as teams operate in decentralized modes, there's a lot of teams making a lot of changes. And with some of the new paradigm shifts in development, you can imagine that there's codes getting checked in everywhere. There's workloads getting deployed everywhere, which could then eventually mean that the services that are detecting these changes and/or are monitoring these changes will also report constantly findings and report alerts. Also, we find that where there are dynamic resources getting deployed constantly with either container registries and/or microservices, again in the CI/CD pipeline framework, you'll see that alerts are constantly getting generated. So in this haystack of alerts, how to find where exactly do you want to go and take actions, how to prioritize some of these things is where we constantly hear from customers that they need help and support, and also need some ideas on how to orchestrate some of these things. So we wanted to share what are the best practices to detect and respond to security alerts in large-scale cloud environments, especially as the data is increasing, the volume is increasing. What are some of the best practices that you can put into your day-to-day engagements by making sure that you're not only detecting but also responding effectively in your incident response paradigm? So before we go in there, wanted to provide an overview of what AWS security services are available in this use case and our domain and how they can help. So AWS has a wide array and a breadth and depth of what we call our threat detection, monitoring, and response suite of services. These services are natively integrated with AWS workloads and are all available at the AWS account level. They can literally be enabled at a matter of few clicks. So what you see on the left-hand side are the three detection services. That is Amazon GuardDuty, that is primarily focused on helping detect malicious and/or suspicious activity. Amazon Macie, that provides customers context around the risk and the posture assessment of their sensitive data stored in S3. Amazon Inspector, that's primarily focused on vulnerability management and actively providing alerts and findings based on vulnerabilities in the natively integrated workloads of AWS. And all these findings can then be aggregated in our centralized security monitoring and cloud posture assessment service, AWS Security Hub. So Security Hub is where customers can aggregate these findings and also evaluate controls of their AWS accounts and resources to understand if they are deviating from security best practices. Then there are two other services that add value. One, especially when it comes to correlation. One of them is Amazon Detective, which is focused on building a behavioral graph database by taking all the findings as well as taking the log information and creating a behavioral graph database that actually customers can leverage. And it's something that exclusively is available in the AWS console. You can use it in the console and traverse through this behavioral graph with the visual graph visualizations now within the console itself. And then finally, the recently announced as of last week, Amazon Security Lake. So Security Lake is our service that helps aggregate, centralize, collect all the log information that a security team would require, but also not only collect and aggregate it, but transform and normalize it into a standard schema format so that security teams have the flexibility to easily act on that data or take actions on that data. So these are the six key services that we will focus on today. And as we go through, I'll highlight what are some of the key elements that we provide built into these services that incident response teams can then leverage and put them in practice. So first and foremost, Amazon GuardDuty was one of our primary threat detection and monitoring service. As I mentioned, GuardDuty is natively integrated with AWS workloads, and in the recent past, lately as this year, we've scaled the service to support new AWS workloads. So once GuardDuty is enabled, it starts collecting telemetry from network activities such as flow logs, API activities such as CloudTrail, and then we've enhanced the feature set of the service to now support workloads such as Lambda, workloads such as EKS, both control plane as well as runtime monitoring, so that we can bring in both control plane activity as well as the host activity where the container might reside. And then additionally, RDS protection so that we can also monitor Aurora databases that might be provisioned. Now, once GuardDuty collects all this information, it sends all that information to its managed threat intelligence engine, which is curated by AWS-generated threat intelligence, as well as threat intelligence from our partners that is automatically brought in and managed. Now, customers have the flexibility to also bring in their own threat intel, and that's what helps detect known threats. So anytime we see, malicious activity from a known bad IP address, Tor node, or a URL or a domain, that gets flagged as a finding in GuardDuty using that threat intelligence. Additionally, GuardDuty also leverages machine learning, which is leveraged to highlight any unknown activity or suspicious activity. So like if we are seeing, data exfiltration attempts on S3 and or we are seeing, any anonymous user access, et cetera, that can be highlighted using that machine learning model as well. And we've also scaled the service to now include scanning workloads actively as well, which means customers have often asked that, if there is a known bad IP address or a command and control type finding that's reported on an EC2 instance or a container workload, would we want to confirm whether or not that actual workload is now compromised? So we've actually enhanced the service to use those findings themselves that are generated by GuardDuty to trigger an automatic scan of the workload by easily creating a service account snapshot and then providing a finding back to the users and customers if we do find a match for, let's say, a Trojan or a malware in that workload. So again, over the last several months, GuardDuty's feature set has improved and expanded. So I think customers who are leveraging GuardDuty already in their accounts can actually go in and opt into some of these new features that are now available. Now, the findings in GuardDuty are the ones which are where we provide a lot of contextual value. Like I said, this is a great detection service. So once it detects, it generates findings. These findings are available in the AWS console and are also sent as JSON events into the event bus queue that is Event Bridge. These findings are now resource types. So you can see here all the different resource types that GuardDuty supports now natively within AWS. And as we've been adding new support for for example, Lambda, RDS protection, or Kubernetes or runtime protection, those are all different categorized findings. Additionally, these findings also provide information around the threat purpose aligned with the MITRE ATT&CK framework. This gives more context to the security teams as to where in the journey the threat actor might be, right? So if it's like a reconnaissance type finding, or if it's like a, a defensive type finding, or execution type finding. So those are actually elements that we already report in the finding as to who the threat actor is, what the threat purpose is, and we align it with the MITRE ATT&CK framework. If you look at a finding example of GuardDuty, you'll notice that there's a ton of information here again, and also available in the JSON format as well. But this is a snapshot of how a GuardDuty finding looks like in the console. On the very top is the description of the finding, highlighting what resource was impacted, and it includes the severity, which is a severity that we generate as part of generating the finding, as to how severe that threat might be in that account or on that workload. We also include information on recurrence patterns and or the count of the finding. So if we see the same finding originate again, we will increase the count on that finding. And then in addition to that, we are also providing customers with remediation as well as response recommendations. So what you see on the far right-hand side is a snapshot of that finding with the help tooltip that is available as part of our documentation, where we provide some guidance to customers as to what could be the suggested steps that they can take to remediate or respond to them. But then more importantly, where does that response need to happen? For example, what was the resource that is impacted? And then who was the threat actor? What were the tags on that resource that was reported in the finding? And who was the threat actor? So where did the threat originate? What was the source? In the case, it's an IP address or a URL. And then we also provide some additional detail around if it was a threat intel match, like where and how did we find that, which threat intel source did we match that known threat with. And all information, again, is available for customers to actually then act on or orchestrate or use that for contextualization, which is what you'll hear as to how this all can be leveraged. Now, Amazon Inspector, again, is an account-based service. Once enabled at the account level and multi-account level, it can then automatically start collecting the inventory of the resources that it supports for vulnerability management. So today, Inspector requires no additional component or no proprietary agents, et cetera. It's a agentless service. Once enabled, it can detect vulnerabilities in EC2 instances using the existing SSM agent, or agentless scanning for container registries in ECR, Elastic Container Registries, as well as now, as of last few months, now Inspector supports Lambda function scanning or standard Lambda function scanning, as well as Lambda code function scanning, integrated with Code Guru and Code Whisperer. So that's, again, a good feature set that allows both developers as well as security teams to be able to leverage this service to detect vulnerabilities, not only in operating system packs, but also language packs, as well as now code. So Inspector, as today, also announced the ability to export a software bill of material from the service as well. So that's, again, a key feature that helps customers have visibility into what all inventory do they have of the resources, and then that software bill of material can be leveraged for either for compliance or regulatory purposes in the required formats. The Inspector findings are actually stateful. So GuardDuty findings are an event that occurred and we generate a finding. The difference between Inspector findings are that we actually go and update the finding status as well if that vulnerability gets addressed, or the customers actually go in and take action on that vulnerability. But the information that's included here is, again, available in the AWS console, as well as these findings are generated as JSON events. So the account information, the severity, some of the key elements that we've added are is there a fix available for that vulnerability? Which is, again, important to know, because that ways you can actually just use what is the fix available, and on what packages do you want to apply that is also something that we include in the finding details. And then the recommended steps. So if there needs to be just a command that needs to be run on that package, or now with the code function scanning, there's actually a very cool feature that we actually tell you the location of the vulnerability in the code. So what line number that code is vulnerable at, and then the recommended action that needs to be taken. And with all this information and pairing it with the CVSS score, as well as the recommended remediation steps, again, customers can leverage that context to take actions on these findings. Next is Amazon Macie. So Macie is, again, our service that is account-based as well as enabled at multi-account level. And once enabled, automatically generates an inventory of your S3 buckets as well as the objects in that S3 bucket. One of the key features that has been enhanced in the service is that not only it's natively integrated with S3 buckets, but it also provides visibility into discovering sensitive data at scale. So it starts evaluating the control plane of S3, starts monitoring any changes to that. For example, like, what are the policies around encryption? What are the policies around identity and access management? Shared versus non-shared buckets, et cetera, and objects. And then provides customers the ability to scan those objects using pattern matching and machine learning to identify sensitive data. The feature that we enhanced in Macie, which was originally based on creating jobs and scanning for sensitive data and objects, has now been automated in the form of automate sensitive data discovery feature. So this is now available, again, at the account level, and once enabled, it automatically, intelligently samples less than 1% of the total objects that are available in S3. And then starts matching them against what is defined by customers, which is sensitive. So customers can define, like what is sensitive data. For example, they can say, use the managed data identifiers, which are already a match for some of the well-known data types, like financial data types, or healthcare data types, or personal PII information, as well as credentials and secrets. Or customers can define their own custom data types, which could be regular expressions that you can define, and then use that collection to then do a match against the automated sensitive data discovery at scale. And what you see then in the console is a data map. That data map is providing you visibility into the sensitivity score that we define for that particular bucket as well as that particular object. So this is available at the organization level, at the account level, as well as at the bucket level. And this sensitivity score is reflected in the findings as well. So this is how a Macie finding will look like, where you can see the detailed information around what was discovered in that object. So account information, severity, which bucket did we find that match, what were the sensitive data types that we matched, like whether it was financial, credit card type, or it was personal, like first name, last name, social security numbers, et cetera. And then what was the count of the matches that we found and the closest location where we found that. Also, we provide information around the policy aspects of those buckets and objects, like what was the access control permissions or encryption policies on those buckets and objects. All of these findings are automatically aggregated in Security Hub. So AWS Security Hub is our centralized monitoring as well as cloud security posture assessment service. Not only is it bringing findings from AWS native services, but it also integrates with third-party tools and partner tools that can bring in findings from those services as well. And then additionally, it's evaluating controls which are grouped together in easy to infer security standards. So security standards are our way of grouping these controls into like well-known like CIS benchmarks, NIST standard, or our own internal AWS foundational security best practices. These are aggregation of these controls to ensure that customers can follow like security best practices and see if there's any deviations. And if there are deviations, then Security Hub will generate those findings as well. That'll be available with the rest of the aggregated findings. Now, these findings now, as of today, we've announced a new feature, which is the automation rules in Security Hub, which means that customers can actually generate or create conditional conditions on the attributes of the findings and either change the severity of the finding or change other attributes so that when those findings are going for response and remediation or downstream workflows, you can actually then automate that action based on what has been defined in the rule workflow. The findings from Security Hub can easily be integrated with built-in integrations in the service itself, which are commonly used by customers such as, like ticketing tools, or, you want to send the finding or the alert to, let's say, Slack, or you want to open up a ticket in Jira or ServiceNow, et cetera. So some of these integrations are already built in, but they're also available in EventBridge as individual JSON events so that you can then either create custom CloudWatch actions to take collective response and remediation actions, or call in step function and Lambda to take individual actions. So one of the other key elements of bringing the findings into Security Hub is that it standardizes all the findings from native AWS security services as well as other tools into Amazon security finding format. So ASFF is a standardized format that allows to easily parse these findings based on their context and based on the content. So things like account information, when was the finding first and last observed, what severity and product did the finding come from, and then what are the remediation guidance are some of the things that are available in the ASFF details. Also, customers can also view an overarching view of their security score based on the standards. So this is what will look like if you were looking at an individual control score, or you can score across all enabled controls can also be viewed at a high level. This gives you not only a visibility into the overarching risk posture, but also you can dive deeper into individual standards and then go further down into individual controls as well to look at these individual findings in the console. Then finally, in addition to bringing findings, we heard from customers that they also wanted to aggregate and bring in all the log information. And that is where Amazon Security Lake comes in. So Amazon Security Lake was first announced at reInvent last year, and now it's generally available and was announced last week. Security Lake is a service that's again available at the AWS account level. Once activated at the multi-account organization level, it automatically starts bringing in log information from natively integrated AWS log sources, such as CloudTrail, flow logs, data plane events from S3 and Lambda, as well as findings from Security Hub. So automatically, all these logs that are selected at the account level will be aggregated in a customer-owned S3 lake formation bucket, and then also gives the ability for customers to bring in other log sources as well that they might have for security purposes. So these could be SaaS applications that you're using in your organization, or could be other applications, whether they're on-premise or in other cloud providers as well. So it gives you the ability to bring in all that log information in one place in a customer-managed S3 lake formation bucket. Once customers have full access and control over that, it also gives customers the ability to set things like lifecycle management, like how much data do you need, which needs to be in hot storage for analytics, or how much data do you need for retention and storage purposes. And also it transforms and normalizes that data in a standard schema format. This is again our aim at making sure that we can democratize the security finding format so that when it comes time to either running queries or analytics, it's much faster and easier for our customers. So Security Lake gives customers the ability to then choose the flexible choice of how do they want to act on that data, or what analytic tools do they want to use, whether it's AWS analytic services or their existing SIEM, SOAR platforms or XDR platforms. This is an initiative that we launched last year It's an open standard initiative where Amazon was a partner, launch partner, open cybersecurity schema framework. And this is the transformation that Security Lake does automatically on the AWS logs that it's integrated with. So it brings in, aggregates all that information, and transforms all that information in a standard schema so that when you're looking for like simple attributes like IP address or entities like network source, et cetera, you can easily find that information. Any ISV vendor can actually go and join this initiative. Since its launch last year, we have seen about 60 plus and growing every day, independent security vendors as well as other ISV vendors who are taking part in that. And then that means their applications are generating logs in the OCSF format. So just to wrap up here, the layered security services are built to allow customers, enable them with one click easily. Multi-account management is also available. That means it can be enabled at the org level very easily so that security teams can delegate a centralized management account and aggregate all the findings in one place. There is no requirement to enable logs for any one of these services. They automatically, being cloud native, are talking to the telemetry that's needed and bring that telemetry automatically into the services. So there's no requirement of enabling log sources, which is, again, a big advantage for customers. And then, as I highlighted, each one of these services reports findings to act upon with all the contextual details that can be used to then orchestrate easier response and remediation actions. Now, talking of responding at scale, I'd like to bring on Scott on the stage now to share some of the examples of how you can use that information and context to act or respond at scale.
Awesome. Thanks, Himanshu. Hey, everybody. I'm Scott Ward. I'm a principal solution architect. I work on the external security services product team. I spend a lot of my time working with customers to help them understand how our services work and how they can incorporate our services in their environment. And then I also work with a lot with the product and the engineering team that actually builds these services to partner with them to make sure that what we're building actually is going to work for customers and help them meet their security goals. So Himanshu spent a lot of time talking about some key services here. Inspector, Security Hub, GuardDuty, and Macy are four in particular. And there was a common theme among all of those services. If you looked off to the right, every one of them called out taking action. So these services do a very good job of extracting information out of the AWS platform and boiling that up so that a customer can actually see those and do something with them. But just turning on the service and having generate those findings is not enough. You need to have a plan. You need to have an approach of what you're actually going to do and consume those findings, especially at scale, so that you can actually do something with them and address the threats in a timely manner. So taking action, what does taking action actually mean? Like if you ask anybody in this audience, everybody probably has a little bit of a different opinion of what taking action means. There's a couple of examples that I have in talking with customers. One, it just means notifying, somehow getting that information out and to the right person so that they're aware that this finding has happened and they can take some ownership or responsibility. To some, taking action actually means full remediation. It means that they're going to walk this thing through an entire workflow and they're going to resolve the security event all through automation or getting it to a sense of closure. And the one I like the most is just it's somehow operationalizing that particular event or that particular finding, getting it into the operational workflow that works best for you and the teams that are ultimately responsible for investigating and addressing that particular security finding. How can you do it? How can you actually take action? Well, every one of these services has a console where you can go in and you can take a look at the findings. You can see all the detail that Himanshu talked about earlier. You can get an understanding of them and you can make a determination of what am I going to do with this? Maybe you'll cut a ticket on each one of those. But at scale, looking at all that stuff in the console, that can be a little bit overwhelming. You have a pretty good chance that you're going to miss something, that you're going to look at something in the wrong order. It's not very efficient. It's not the best use of your time. You might switch to calling the APIs. Every one of these services has an API that you can call to get a list of the findings, and that's better because you're starting to let the computers do the work, getting information about those findings, and you're in a better chance to maybe programmatically hand that off to something or somebody else. But you're also regularly having to pull these APIs saying, hey, what do you got for findings? And you got anything new for me? And you're having to compare that with the last time that you got findings. And so it's maybe not the best use of your time to be regularly polling and saying, hey, you got anything new for me? And then you have event triggers. You actually have, this is a case where you're sitting back and you're waiting, you're letting your systems wait until something is actually happening. You're receiving a notification that an event has happened, allowing you to optimize how you use your resources and how you're using your people to only need to do work when it actually is needed. So what are some examples of taking action? Well, one is just enrichment of the data itself. And there's a couple different ways you can go about enriching. It could be taking the actual findings that are coming out of these services and adding additional information to them. It could be adding who's the owner of this particular resource or this particular account, especially if you've got all that information, maybe in a different configuration system. Could be adding pointers to relevant log data for that particular finding. It could be adding information about a particular playbook, or it could actually be just going out to the resource where the finding was generated for and adding some additional data onto that resource itself. It could also mean just taking action, could mean taking this thing and inserting into whatever the tools are that you want to use to be able to operationalize this. It could be putting it into a ticketing tool, some sort of a chat ops integration, adding it to some sort of a SIM or an analytics tool, or some sort of a security orchestration tool. Those are all legitimate use cases and ways that you could be taking action on these particular findings. And these are all relevant to helping you deal with this at scale. So I talked earlier on the event-based approach. And so let's go back to that. All of these services that we talked about a couple slides ago have that integration where they can take action. All of these services are sending their findings to Amazon EventBridge, and EventBridge is the AWS message bus service. And so the way that these work is that every one of these services is going to generate an event or a finding. That's going to be a copy of that is going to be sent to the EventBridge service. And EventBridge, you can go in and define rules. And in every one of your rules, you can define a pattern. It's what you're looking for inside that particular message that was sent to EventBridge. And so those patterns or rules can be very broad or they can be very specific. So very broad may mean you're looking for all findings coming from the inspector service. Doesn't matter anything else, I just want to know that it came from inspector. Very specific could be that I only want findings coming from inspector that have a severity of high and are associated with EC2 instances with these particular tags. And once you've defined the pattern that goes with your rule, you then define a target. Now a target can be one of 20 plus AWS services like SQS, Lambda, Simple Notification Service, AWS Step Functions are all legitimate services to have as targets. But your target can also be a partner solution. So there are many partners that are integrated with EventBridge where you can actually route that to an HTTPS endpoint that the partner stands up to consume your findings. And on top of that, you may have certain use cases where you want to modify or you want to insert this into multiple tools. And so you can actually define multiple targets. You may have a particular pattern that it's so severe, you want to get it into the hands of your security team quickly, get it into a chat ops tool, but you also want to cut a ticket for that so they can use it, or you want to get it into your analytics system still. So you can have multiple targets for these rules. So I want to talk through just a few examples of what this might look like and what we actually see from some of our customers. And then we'll bring Matt up here to talk a little bit more about further ways that you can look at this and how you can actually implement this type of approach in your environments. So the first one is just funneling everything to an operational tool. Many customers have invested in their analytics or ticketing platforms. They don't want to change that. They've also realized that services like Security Hub do a really great job of funneling and consolidating all of that AWS specific information. So they standardize on Security Hub to pull all that information together, let all the findings flow through to EventBridge, and then depending on what that operational tool will support, they'll choose the appropriate target. Could be a Kinesis data stream, could be a Lambda function that is reformatting the data before it goes off to the tool, or it could be like a simple queue service where the operational tool maybe isn't running in AWS and it runs in their own data center and it needs to pull that queue for new findings periodically. And then from there, you have the ability to do your reporting or any investigations. tagging the sensitive data. So we talked earlier about enriching your data and applying tags to the resources. So in this example, we actually have Amazon Macy that scanned an S3 bucket. It's identified sensitive data. That finding's been generated and sent to EventBridge. And in this case, that target is a Lambda function. That Lambda function's purpose is to extract the bucket information from that finding, and then go in and apply a tag to that bucket indicating that sensitive data was found in that bucket. And by doing that, you have the opportunity to actually implement access-based controls. So you might have identity policies that are preventing access when buckets are tagged that certain way, or granting access when they're tagged that way. You might use that in some of your operational reporting when you're looking for abnormal events that might be related to buckets that are tagged certain ways, or you might be using it to influence the Macy service itself as far as preventing it from doing any more scans because you've already know that there's sensitive data in that bucket. We have some customers that have taken that remediation guidance that Himanshu talked about earlier that our services provide and decided that they want to standardize that, and they also have their own runbooks on top of that around how they're going to handle certain events. And so they publish all of those runbooks and pointers to those runbooks in a central database. And in this case, they actually use that taking action step to use a Lambda function to look up a particular runbook that is specific to the type of finding that's coming through, associate that with that finding, and then pass it on to their operational tools. And what that means is that, let's say you have a ticket being cut, the moment the team that's responsible for resolving that ticket receives that finding, they also have the appropriate playbook that's going to allow them to investigate and go and ultimately remediate that type of finding. Some customers want to take a more surgical approach. They actually want to go in and they want to implement some preventative measures that stop a particular action from happening anymore. So in this case, we actually have an event coming from GuardDuty where a target is a step function where you have multiple Lambda functions. The first one is just extracting the threat actor information from that particular finding. The next one is actually running another Lambda function to create a rule on a network firewall that will block inbound and outbound interactions with that particular malicious actor. That rule is immediately applied to the virtual private cloud that firewall is associated with, and your resources running in that VPC are now blocked from interaction with that malicious actor any further. We also have customers that are looking to remediate misconfigured resources, and so taking in events, we talked about those security standards and the controls earlier, taking in events related to misconfigured resources that don't align with best practices and using these events to orchestrate flipping those resources back to what their secure and best practice state is. Along the way, building in, maybe setting some notifications, getting some approvals before you actually go in and update that resource back to its known state. And then finally, you have the option to just add additional context. So we talked earlier about adding pointers to log files that may be relevant to that particular finding. So in this example, we're standardizing on Security Hub again. We're letting that event flow through, and we're using a target of a Lambda function to look up some additional log information from logs that would be relevant for that particular type of finding, and including that log information with the finding as it's sent across to an operational tool, or vice versa, we're actually letting the operational tool connect with Security Lake so that as soon as that finding is received, that operational tool can go in and enrich that data so that you have more information as you do your investigation. So how do you respond? I've talked a lot about the need to respond, how that data flows out, and some things you can do. How you respond is going to matter in a couple of ways. One, it's going to depend on what your current capabilities are. What is your engineering skill set? How big is your team that can actually build some of the things that might be needed to incorporate all of this information and route it appropriately? And it also does depend on what are the operational tools that you have in place today. Do you have those tools? Do you need to go and find those tools and figure out what makes sense for you? It also depends on what your risk is. So we generate these findings with the context we have, but your risk is also going to depend on what's important to you. And this is where context matters. Having an understanding of the environment. Is this a production account or is this a sandbox account? What is the workload or what is the application that this particular finding is for? Is this for a very tightly controlled PCI environment, or is this something that, once again, was stood up in a sandbox environment and is going to get torn down in the next 20 minutes? Make sure that you have context built into how you are looking at the data coming out of these services, because it's going to help influence the type of action you take. And if you're going to take a action that is you cannot recover from, something that's more of a one-way door, or if you're going to take actions that you're more comfortable with because you understand what the environment is and what the result of that action will be against that particular resource in that particular environment. So with that, I'm going to hand it off to Matt, who's going to talk more about strategies and approaches you can take to actually deal with this scales event coming out of AWS.
Thank you, Scott. So my name is Matt Dorensky. I'm the Director of Cloud Security at Comcast, and wanted to talk a little bit about some ways that you can handle cloud detections at scale. When we're dealing with lots of different detections, many different AWS tools, third-party tools, custom written detections, and we're dealing with multiple security consumers, multiple organizations that want those detections, we need to be able to give people the same answer every time they ask and have everyone asking the same question the same way. If that makes sense. So I wanted to talk a little bit about that. I want to go over kind of what it looks like when we operationalize, kind of like what Scott's been talking about, when we're just dealing with a single service. So we detect a vulnerability, we pass that on, maybe we send it to Security Hub, maybe it goes to EventBridge, S3. We're going to do something with that. And this is pretty straightforward when we're just dealing with a single service. But it becomes challenging when we want to ask a question and we have multiple teams asking the same question. So in this example, how many vulnerable databases exist in the environment? You could see a CISO coming and saying, hey, how many of these do we have? And depending on what team you ask, you may get a different answer. It's not so easy to define. You may ask the vulnerability management team and they're going to go through and they're going to say, well, we're going to scan and we're going to figure out how many CVEs we have. You may ask the network security team and they're going to say, well, which of those databases are exposed to the internet? Like those could be vulnerable. You may ask the identity team, how are those databases authenticating? So it becomes difficult to define and we have to get really specific and say, this is what we mean when we ask this question. You could have multiple detection sources here as well. Again, the vulnerability team could be looking at their vulnerability scanners. The network team is going to look at network configurations. The scope could be large. Which databases are we talking about? Managed databases, databases running on instances or servers, and you've got multiple security stakeholders that are interested in this data. So we're operating at a scale with a seemingly very simple question, but you ask a different team and you get a different answer, and that can really make things difficult to operate. So we want to make it easier to operate at scale. We want to make it repeatable and consistent. So the first thing that we have to do is deal with this issue of multiple sources. It's always good to have a variety of tools that we're working with. So again, we've got our vulnerability scanners, we've got all the tools that AWS is talking about, we've got our third-party CSPMs and third-party tooling on our custom alerts. These are all sending us different pieces of data. The problem with this is that very often they're in different data schemas. They may be operating on a push or a pull, they may be event-driven, they may be scheduled, but most importantly, like Scott was just mentioning, they almost always lack context. They don't understand the layered approach to security. They don't understand what mitigations may be in place. And so you may get a response that says, hey, these databases are vulnerable, but you've got other mitigating controls in place that mitigate that vulnerability that a tool may not know about. And the data currency can be different between these tools. One tool may have data that's very current, event-driven, you're getting now, and another tool is coming in saying, a scanner, hey, I checked this database a day ago, 2 days ago, a week ago, and you're getting a different answer. So this has quite a few different impacts when you're trying to deal with these alerts at scale. Someone asks the same question and they get different answers, potentially from the same team running the same query a little bit later in the day. You get the inconsistent definition of the same alert like we discussed, and this really drives teams to independently integrate with multiple data sources. So now your vulnerability team is going to integrate with multiple sources. Your investigators are going to integrate with those same sources in a different way for their tooling. You're duplicating effort that drives up your costs. You're duplicating data. You're egressing data into multiple stores, and it becomes untenable at some point. So how do we solve for this? What is one of the solutions here? We want to abstract that data away. We want to get customers away from the data sources and create a clearinghouse. We want to be able to ask and define questions in a repeatable way so we're always getting the same answer. We're using one set of business logic, and we're making it flexible in how we get the answer to that. And I'll demonstrate how this looks in a few slides. But we need an ability to support all of our different stakeholders who are asking these questions while reducing the duplication. So we have to answer questions for the vulnerability team, the incident responders, the CISO, all these different players that are coming and asking for this information. The other thing that abstraction does is that it enables data consistency across the teams. So again, if there's one place to go to ask for this data, we ask, what are my exposed databases that are vulnerable? That's been defined as a specific detection in the abstraction layer. And every time we ask that question, we know what the logic behind that question is. We're going to get the same answer, or at least the answer was produced in the same way. So there's no question about how the data was collected. The other thing that it lets us do is enrich and do data correlations of the detections and add our specific business logic and mitigations into that loop. So you have a vulnerability scanner that says, hey, I just found this vulnerable database. I'm going to raise this up to the incident response team. It's critical. By adding in your own business logic, you can say, yes, you've detected that, but it's not critical because we have these other mitigations in place that are preventing external access or from people being able to hit that database. The other thing with the enrichment is many times, especially in the context of native tools, they don't understand who to contact for a given account or for a given owner of a service. And so we can enrich that information with back-end CMDBs and other sources of truth so that when the incident responder gets the alert, when the downstream system gets the notification or we're sending it on to the person who can take action, we know where to route that thing. They know who to contact. So how does this look kind of visually when we're actually operating with this type of a framework? So very simply, there's going to be an event. That event needs to be validated. We're going to do some checking against our business logic, against our environment to say, is this legitimate? Once we've validated it and we've said, yep, this needs to be addressed, we're going to collect some additional data. We're going to do that data enrichment phase. Once we have that, we can dispatch the alert. And so the alert's going to go to whatever the consumer is, and the finding's going to get dispositioned. So maybe you send your alert off to your vulnerability management system, and that vulnerability management system notifies the customer from the data that we provided in the enrichment. The customer's going to disposition that. They're going to fix it. And then we have this feedback loop that we put the resolution back through this abstraction layer so that it can close the loop with vulnerability management, and we resolve the issue within the system. So some potential tools kind of listed here. I'm not going to go over quite all of them in the interest of time, but you can see that there's different tools that plug in and integrate at various layers of the abstraction framework. So what does implementation actually look like? I'm going to briefly touch on this, and then I've got a diagram that we'll go over in more detail. But the primary focus here is to be primarily event-driven. We want to be able to integrate with the most diverse set of tools and the most diverse set of data sources so that our correlations are the best that they can be, our enrichment is proper for the consumers that we're going to integrate with the service, and we want to do the heavy lift for those consumers. So as we're getting these disparate schemas in from our different detection tools, we want to format that schema, do our work against that finding, and then once we've determined where it's going to go, reformat that into the schema that the consumer's expecting and provide that down to them. We don't want the consumer to have to do that work, do that heavy lift. But what we also want to do in this case is to not expose the data sources directly to the consumers. The whole point of this is to provide that value add back to the data consumers so that they don't have to seek out that original source. And we do that through APIs and CLIs, and we broker that access. So what does this look like visually? So I'm going to kind of walk through this example of what an abstracted architecture could look like. So we start with an event, and an event can be emitted from any one of our data producers. In this case, we've got AWS Security Hub. So we emit the event over to AWS Event Bridge, and that event bridge has a rule set that's going to tell where we want that to go. In this case, we're going to send it to a set of lambdas that does triage and routing. And the triage and routing will take other data sources if we've got, say, custom feeds that are coming off of config when certain configurations trigger, or our CSPM. Any other types of detections feed into that same triage and routing lambda. And that has a set of rules for every detection that we want that says, here's what you're going to do with it, here's how you route it, here's how you're going to rank and rate the severity of the finding. Here are the downstream consumers for the various severities. So it's got a configuration file that determines what we're going to do when we get any specific event from any given producer. Once we do that, we're going to send it on to schema normalization. So again, we're getting all of these different feeds from our different security sources. We're going to normalize that to a consistent internal schema within the tool. Then we're going to run what I call skills. And these are validations. These are making sure we don't have false positives. It may be something as simple as an Nmap scan. Hey, I got an alert that says this thing is open to the internet. Let's run an Nmap scan and actually check and bring that information back into the alert that we can then decorate within the internal schema. You could come up with any particular number of skills that's relevant for your use case. But the goal is that these are assisting with the identification of false positives, data decoration, data enrichment. I have a specific call out for a data decoration phase where we have just a normal set of things that we know we want every alert to carry with it. This could be things, well, certainly like who's the primary owner of this event or this resource that had the event, so it can be routed properly. You may want to add things like cost center, leadership contacts. There could be a myriad of things that you want to decorate as part of your alert. Finally, we're going to dispatch it. So once we've gone through the first 3 steps and that triage, the alert is going to have some severity based on the configuration that we set for that particular finding and whatever modifiers that may be part of that finding. If something is internet exposed, if something happens to have sensitive data that we were able to pull in through a skill or data decoration or a tag, it's going to modify the severity as it moves through the framework. And so once we get to the end, we're going to dispatch. And dispatching, we are going to format, again, the data into the schema for the downstream system. And there are some examples of some downstream systems on the other end of the dispatch here. You may send this over to just a log monitoring system. You know, it's low severity. We want to know that this happened. We want to store the data so that we can get metrics off of it. But we're not going to necessarily do anything with it. You may send it directly to your to the resource owner, down to a consumer, someone who's going to take that information and actually action it. This could be an incident response team. This could be a vulnerability management system. This could be other lambdas that are going to take it and take action against whatever finding has been produced. Maybe you have a publicly exposed database and you're saying like, yeah, that's too high risk for us. We're just going to put this deny in front of it and shut that off. That could be some automation that gets pushed to. The other thing that you might want to consider is what I've put here as the deployment database. And this is simply keeping a record of all the current and closed findings that have been generated by the framework so that you can then expose those to other consumers that may want to query that via an API. So not necessarily creating a ticket interface or creating something akin to like a ServiceNow or something like that, but just being able to let users query this information so that they can see what the posture of their account is, of what the overall accounts are, and exposing that through APIs and CLIs. So that's technically kind of how you could put this together. But there's another component to this, and that's the people component. That's really important. So how do we manage our stakeholders? And there are multiple stakeholders in this scenario. We've got security teams, we've got resource owners, we've got executives, we've got multiple people that are involved here. And it's really important that we be as responsive as we can and we make sure that the system is operating as we expect. And we do that through as much automation as possible. So we're looking at things that I call alerts as code. So you are taking those definitions of your alerts that I talked about during the triage Lambda, and you are canonizing those in your code repositories. They're going into GitHub and they're going through CI/CD. We approach it in a minimum viable product approach. So we're starting with basic alerting, and then we're embellishing on that over time. We're adding things that the customers are requesting, the data consumers. But we also have logging and monitoring in place in the form of canaries. So I expect an alert to operate a certain way through the abstraction system. I'm going to actually trigger that event, and I'm going to have monitors in place along the way that time it. How long does it take to get from one end of my pipeline to the other? Is it hitting all the right skills? Is it hitting all the right data decorations? And is the answer I'm getting out the other side consistent with what I defined in my alert as code? The other thing that you would want to consider is all of these alerts that you're developing as code need to be exposed to your consumers. People need to know what alerts you've created and what their status is. Something that I would call the alert status page. Just a chart that's, I've got these alerts, here's the state that they're in, here's what we're developing, here's the canaries when they last ran and the results were good, or something's under construction, something's being improved. But all that is to say that your alert documentation and the way that you're exposing what you're detecting to your customers is really important. The next thing that then comes to mind is, great, I've got all these stakeholders, I've got my automation, my documentation, but people are now going to ask me for all kinds of new alerts, and they're all going to want their stuff first. How do I deal with that? So one of the ways that you can deal with that is what I call budget day. And budget day is pretty much exactly what it sounds like. You give all of your stakeholders a budget. So here are some example stakeholders that we've got, and they've all got points. And you allow your stakeholders to come in, and you allow them to put alerts into your backlog. So your threat hunters might care about something, and your application security team might care about another thing, and your incident responders care about a different thing. They all get to come in and tell you what they think is their top priority. And then on some regular basis, whether that's once a quarter, once a month, whatever is the right cadence for your organization, you have budget day. Everyone comes in and votes on what they think is the top priority, and you kind of democratize the entire process. And top number of alerts wins, and whatever you're able to get through your alert development pipeline is what makes it into production. This is really great because if you look at the chart, cloud security has the most points. In this model, they can outvote anyone unless your stakeholders start working together. And if your stakeholders are working together, that's great because now they're talking about what's most important for them, what's best bang for the buck, and then even though they're then able to pool their points and kind of outvote everyone, but you're able to meet multiple customer needs with single alerts. So what are some gotchas that you may run into with an approach like this? The first one is consistency in consumer stores. So you've got all of these consumers, they're getting data from you, the data you're feeding is up to date, but the data consistency that they have may not be up to date. So as you're plugging in consumers, and we're helping them do that by modifying the schemas for their needs, you want feedback from those systems. If you're pushing data out there, you want some reply that says, yep, I got that information correctly. I processed your closure notice, or I processed the open ticket correctly, and an ability to replay those messages if the system says, hey, I didn't hear what you said, please replay it. The other thing that is really important is alert fatigue. It's very easy to create alerts through this framework and just flood downstream systems with alerts. So it's really important to curate your alerts properly so you're not overwhelming downstream systems, overwhelming your developers, and just making it really difficult to triage the things that are most important. This is not a project, this is a program. So it's really important that anything that you apply through this process is thought of in that context. You always, you want to reach version 2. So I'm going to talk a little bit about kind of how you get started with this, but the important thing is it needs to be a program, it needs a roadmap, it needs program management. You want to get to V2, 3, 4. The the other issue is, we talked about context. It's really important that all of your alerts have good context. So as you're writing your alerts, make sure you're pulling in that context, make sure that you're pulling in that business logic and the known mitigations so that you're giving people actionable, high fidelity alerts as they move through the system. These integrations can be really complex. So we've got CSPM products, we've got multiple AWS products. Integration can be very difficult. And you want to make sure that you're leveraging as much consolidation as you can. So things like Security Lake, other tools that'll help consolidate things for you upstream so that you're doing less of that heavy lift as you get into your abstraction layer. Finally, resource allocation. You will only be as quick with this as you have developers to work within it. So you need to figure out what is the right resource allocation for your use case. Finally, what's next and how do you get started? Don't try to do everything at once. It's really easy to come in and I've got my list of like 40 things that are my most critical and I want to build all 40 of those things. And I've got 4 different data sources and I've got 5 different consumers and they all need this data. Start with one of everything, right? This is MVP. We're going to start with one source, one alert, one consumer, and it's going to take a while. But you want to use that opportunity to build your required documentation, to build your processes, and build the foundation for the abstraction layer. It doesn't seem like you're going to get a lot of value for the amount of time and effort you're putting in, but the second one is going to be that much easier. Use the first one as an opportunity to get your framework down and get it done correctly. Once you have one alert working, tested, deployed, you've got your canaries, you've got your documentation, you've started your budget day, all your processes are in place. Get feedback from your customers. How well is this one working? What do we need to improve? What do we need to do different or better? Because it's your customers that are going to drive the success of the pipeline overall. And again, I'm just going to reiterate on this. It's not a program, or it is a program, not a project. It needs consistent care and feeding. It needs a roadmap. It needs a program manager and a team behind it to keep it working. But if you do it correctly, then you end up with a system that you can now ask questions, you can query, you can get data out to your customers without asking everyone to go back to the original tool sources. So that's the end of the talk. I want to thank everyone for coming out. I want to thank Himanshu and Scott for presenting. And thank you everyone for coming out this late in the day. Did want to remind everyone that there's a survey on the mobile app. So if you could all fill that out, that's really important for us to get feedback on how the presentation went, what we can improve, what we can do better. If you've got questions or comments, we'll be off to the side to answer any questions that you might have. Thank you.